Okay, well, let's start then. Welcome to the Barnfind product overview. I just would like to introduce myself. My name is Manfred Röner from Media Online, which belongs to the Broadcast Solution Group in Bingen in Germany. And as the technical support manager, it's Benno Sonder. He will come back to all the technical questions in detail. Let me start from the beginning. The range where Barnfind is placed is the world of sports, motorsports, especially cars, bikes, also the industry. And that's we are using Barnfind, oil and gas industry, also multimedia, video monitoring, surveillance, and industry applications. But also in the range of broadcast OB vans, especially in StageBox solutions or in stadiums. That's one of the main parts where you can find Barnfind. But not only this, also in the industry, as I mentioned, on the right side you see fishing industry, monitoring, also in the range of traffic monitoring in tunnel surveillance, for example. There you can find Barnfind. Barnfind Technologies was first time officially established in December 2012 in Norway. It's an original Norwegian company. Main part of the developers and people were originally from Network Electronics, later on Nevion. There I should mention Viggo Evensen. He's a long time in the business. He knows the broadcast industry very well. And he is the CEO of Barnfind Technologies. So the start was actually early 2010 when the people came together and thought about how to found Barnfind. Indeed, the company is privately held, no venture capital needed. All assembly and quality control takes place in Norway, very nice city, Sandefjord, in the southern part of Norway. And we in the group are all experienced broadcast and telco veterans, so we know the business quite long. And we also know the way of network or electronic production and development. And we have established a large sales network. Nowadays, Barnfind you'll find in more than 60 countries. And we do have very, very many high-end references. Next page, please. Thank you. So where do you install Barnfind optical products? In broadcast applications like in studios, OB vans, between OB vans, stadium, events, transports of signals between floors and buildings, remote production, typically any kind of signals from 100 meter to 100 kilometer distance. So it's a wide range where you can deploy the Barnfind equipment. As I mentioned before, it's you will find Barnfind in the oil and gas industry, digital signage, telemedicine, campus, government, industry, house of worship, CCTV, security, defense, entertainment, events, and education. So it's a wide range where you can deploy Barnfind as a product and as systems. Next page, please. Here you find an overview, and as the slogan says, one fiber, all signals. And that's important to know. Barnfind has literally no delay when it comes in transport of signals. It's latency loss, and transparent for all these kind of signals. That means we see video signals, analog video signals, MADI signals, HDMI, AES audio signals, DMX, light control, 10G Ethernet, 1G Ethernet, analog audio, GPI interfaces, and of course the 100 or 10 megabit 1G Ethernet connections. So it's a wide range of signals you can use and feed through a single wavelength or a fiber and combine that into one fiber via CWDM, for example. On the right-hand side, you see facilities, buildings where the Barnfind equipment can be deployed, stadiums, arenas, or also in the range of OB vans or SNG cars. Next page, please. Now, to today's topics. Benno Sonder will go into the details, as I mentioned, and he will show all the details for the different type of products. Now, Benno, it's your turn.
Thank you, Manfred. Welcome, everybody, to today's Barnfind webinar, and thanks to Media Online for giving us this platform. Here you can see today's topics. These are the product groups which Barnfind is offering. It's BarnOne, our flagship, one rack unit, 32 square router. It's the BarnMinis. You will get a preview on BarnColor, a product which we are planning to release this year. We'll have a quick look at our passive optic portfolio, multiplexers and splitters. Of course, we do offer SFPs. We have a StageBox breakout panel solution in case you want to hide your sensitive equipment in some flight cases or racks. And of course, we have a control software. We're going to have a look at all those products, starting with the BarnOne Series. BarnOne can have different front panels, but in general, the device is equipped with a 32 square protocol agnostic independent cross-point matrix. It is equipped with SFP or BNC ports. All SFP ports are bidirectional, as well are the BNC ports. You can switch them to be input or output. The SFP is always input and output at the same time. All outputs are reclocked, and we can, in the SFP ports, accept any MSA compliant SFP. That means you don't need to buy our SFPs. You can use your own or purchase your own, use any third-party SFP as long as it is MSA compliant. This applies for the 3G BarnOne frames. I have some more to add later. Every frame has a fan cassette mounted to the rear of the unit, which can be replaced. That means if your fan is broke for whatever reason, you can replace it yourself. You just order the new fan cassette and exchange it. Or in some very seldom cases, you can even run the frame without fans in case you need to run it in a very quiet environment with good ventilation. The frame can be equipped with a redundant power supply, and you can change the rack mount ears to the rear of the device and mount it the wrong way around in your rack. These are the different front panel layouts which are available for BarnOne. As you can see, all frames are equipped with 16 SFP ports. This is the same for all the frames, and then the top row can vary between BNCs and SFPs, or as we can see in the frame called BTF107, it can be equipped with a CWDM multiplexer, either 8 or 16 channels. If you want to carry some audio, we offer the frame called number 10 with 8 analog line level inputs and outputs converting to MADI. Now, UHD is coming, and our frames are usually carrying signals up to 3 gigabits per second. And for UHD signals, we have a new frame called BTF141, which follows the same logistics. It is equipped with 16 SFP ports, all feeding into a 32 square cross-point matrix. And additionally, it is equipped with a slot for a daughter board. Now, this daughter board can be equipped with a board by Barnfind, but it could as well be equipped with a board by a third-party manufacturer. Additionally to the 3G BarnOne frames, in this frame we do accept non-MSA SFPs, and we have a built-in GPIO and tele interfaces, which we can control via an internal management software. So you can, for example, control external applications like optical switches or similar. We come back to that later. We do offer a SFP card for the daughter slot of BTF141, which is equipped with another 16 SFPs to fully fill the 32 square cross-point matrix. The control comes from the main frame through the same software, and it carries any signal up to 12 gigabits of bandwidth. That means UHD as well as 10 gigabit Ethernet and all signals below those bandwidths. So even 100 megabit Ethernet or MADI signal can be carried in any of those slots.
Benno, just one question. That means each and every channel can use 12G single links connection. Is that right?
Yes, Manfred, that is absolutely correct. Each input port can carry 12 gigabits, and each output port can carry 12 gigabits. What can I do with such a frame? We could, for example, have a remote production scenario where we have the headquarters, the TV station, where we have the screens and vision mixers and control, and we have a studio or some other room where we would like to record, where we have remote controlled cameras, for example. All the signals from the cameras, video and control, can be connected to the studio using just one single fiber. And for backup, I can use a second fiber running a different path. In this case of this special application, one path is about 10 kilometers and the other one is about 12.5 kilometers. Both fibers are carrying all signals which need to be transported between the studio and the TV facilities, and an optical switch takes care or decides which of the two fibers is going to be used. This optical switch, which we can see here, is triggered from a GPI coming out of the BTF141 frame. And every time you trigger the GPI, the switch changes the fiber from A to B. Now this trigger could be a matrix change. It could be a loss of service of one or several SFPs. So you can decide, I want to be sure that not only one SFP is losing its signal, maybe two SFPs need to lose the signal, and then I decide to switch over to the redundant fiber. These logic gates are configured in BarnStudio and are stored inside the frame. You don't need any external software to control this. You only need the external software to configure it. Another BarnOne unit I would like to have a closer look at is BTF110AA. AA stands for analog audio because it has 8 analog audio inputs and 8 analog audio outputs. Those analog audios are converted into digital signals and fed into a MADI router. This MADI router has 4 inputs and 4 outputs, and additionally 8 channels coming from the analog interface, making the whole matrix a 264 square audio matrix, additionally to the 32 square main or video matrix, which is inside the frame anyway. The audio card can clock internally, or it can clock to any incoming MADI signal. It can work at 48 kilohertz or 44.1 or 96 kilohertz. An audio signal which is entering the frame through the analog interface is fed into the MADI router and can be distributed to a BNC output on a MADI stream. It can as well be distributed to an SFP output. This SFP output could be multi-mode or single mode, or could even be equipped with a CWDM-SFP to carry the MADI signal along with many other signals on the same fiber. And if you want, you can even output the analog signal coming in back to an analog output. The other way around, any incoming MADI could be on a BNC port, could as well be on an SFP port, is fed into the audio matrix. And from there, it can be distributed to an analog output, or the incoming MADI can be rearranged, the channel mapping can be changed, and you can output it again on any BNC or SFP port of the frame. Is there any questions, Manfred, regarding BarnOne, or shall we?
Yeah, just come back one page. Just go back one page, please.
Yes, of course.
The formats, it can be 44 kilohertz, 48, 88, or 96. Is that right?
That is correct.
And you mentioned internal or external clock. What does it mean in this case?
It means that the audio card, if it's set to internal clock, the audio card is the clock master, and a connecting device can clock to any MADI stream which is coming from this audio card. The other way around, the card can clock to any incoming MADI signal. That means it can integrate into existing audio systems by clocking to the MADI, which is entering the frame.
There's just came one question in from Tan. Can the MADI and analog audio support intercom signals? That's
Yes.
his question.
You mean the bit transparent transport of audio? Is that the question, I guess?
He's asking, yes, he asked, yeah.
The MADI signals can transport bit transparent AES3 signals. Yes, the analog, of course, not.
Okay, thank you.
So I would like to move on to our next product group, the BarnMini Series. The idea behind the BarnMini is the same as behind the BarnOne. It's a protocol agnostic converter which converts between an SFP and a BNC or an SFP and an SFP. And by entering the SFPs, you decide which functionality of the product you would like to use. On top of that, we have more minis with other functionalities like passive optical units, splitters, or multiplexers, or GPIO converters. Some of them are uncontrolled. Some of them are controlled by our software BarnStudio. The bandwidth of a BarnMini varies between 3 gigabits and 12 gigabits, and of course all bandwidth below that, all data rates below 3 gigabits are supported as well, of course. You can run the BarnMini with its standard power supply, which comes, a desktop power supply, or you can have up to 16 BarnMini units in a common frame, in a common housing, which can then be equipped with a redundant dual power supply. One of the BarnMini units that is controlled by software is BarnMini 5. It's a GPIO and serial data to Ethernet converter, converting the GPIs and serial data into TSL protocols. Supports the TSL protocol, Tele and TSL UMD version 4 protocols. Carries up to 4 GPIs and 4 GPOs. You can, they are provided on those 2 RJ45 connectors, and on a separate RJ45 connectors, you have one serial data interface which supports RS422 or RS485. You can use BarnMini 5 to trigger an optical switch, as we've seen before, by sending a ping, and if there is no response to the ping, it can trigger a GPO, or if there is a response to the ping, it can trigger a GPO as well. The unit does provide some information, status information via SNMP. Another unit, which is software controlled, and which is our latest BarnMini, our latest release, is BarnMini 22. It is based on BarnMini 2, which is a SFP to SFP converter. BarnMini 22 now supports higher data rates than BarnMini 2, and it is equipped with the control interface here in the middle. The RJ45 connector is for control. BarnMini 22 is protocol agnostic. You can run any signal with a bandwidth up to 12 gigabits, UHD video, 4K video through it, bidirectional, or you can run a 100 megabit Ethernet signal through the same unit just by using different SFPs. You can control the reclockers inside the unit. We can have a look at that later on when we look at the software. And you can monitor the data provided by the SFPs. That means you can monitor optical levels, which the SFPs provide to their host, to their mainframe, which is very important if you want to check the status of your fiber, which is carrying maybe up to 18 signals. BarnMini 22 does as well supply status information via SNMP. Our next product group are passive optical units. We need those units to combine many signals into one fiber. We do that using CWDM technology, coarse wavelength division multiplexing. That means all those numbers which you can see there represent a different color on a different color of light traveling through the fiber, and the multiplexes are optical filters combining the different colors into one common fiber or one common port, or extracting on the other end those colors again from the common fiber. Those multiplexes work bidirectional. It doesn't matter which direction the light is traveling. As long as it has the correct color, it will run through the specific filter port.
Benno,
Now, yes, Manfred.
just one question concerning the optical filters. Can you go one page back?
Of course I can.
Yeah, lovely. We see here the three different versions of the optical blocks, 8-channel, 16 and 18-channel converters. That means we could distribute the combined signal with the optical splitter. That means when we do have the COM output, where all the signals are mapped in optical, then we can distribute the common output to different locations. Is that right?
That is correct. I would like to go back to the system example which I was showing before, the remote production. We do have an optical splitter here in this place.
Oh yeah.
So the signal from the multiplexer runs into the optical splitter and is distributed to two fibers at the same time, passively. There is no intelligence behind this unit. There is no power needed for this unit. This is an absolute passive unit, very cost effective, and just splits the light coming in here onto two separate ports. The only thing what's happening, the power of light, of course, is reduced because it's split in half.
Okay, thank you.
Another example, what you could do with optical multiplexers. You can have two video feeds, for example, video feeds, but they could be any other signal, entering the multiplexer. Additionally, you could have a data link, meaning an Ethernet signal running into the same multiplexer. All four signals are combined and connecting to the next site. At the next site, we can add in different signals by using different wavelengths, different colors on which the signals are traveling, and all 8 signals are now transported over only one fiber to the next place, to the next site.
That means, there is practically no limitation in bandwidth. That means all channels can run up to 100 gigabit. Is that right?
This is dependent on the optical transmitter which you're using. If you had an optical transmitter doing 100 gigabit on one wavelength, you could run 100 gigabit on each wavelength. Up to my knowledge, this is for 100 gigabit not the case yet, but it might be possible. A usual application would, for example, be to run 4 times 10 gigabits in one fiber, or 8 times 10 gigabits in one fiber. This is possible and a very typical application. And the next example I would like to show is doing exactly that. So we are transporting SDI, which can be 1.5G HD video, or even SDI, bidirectional, converting it to optical over a multiplexer, and at the same time, on the same fiber, on different wavelengths, we carry a 10 gigabit Ethernet link. Now I would like to come to a product which we are launching this year. It will be called BarnColor, because each box will have a different color. You can see here there's 4 different colors are planned so far. And you can get those boxes always in pairs. So you can have a pair of 2 boxes, of 2 green boxes. Boxes will carry 4 SDI signals in either direction over 2 fibers. 1 fiber going one way, 1 fiber going the other way. Now you could have the wish to transport beside SDI Ethernet. You can buy a second pair, but you don't want to have more fibers in place to carry those signals. So you buy a pair B, purple, which is equipped with Ethernet ports, carrying 4 bidirectional Ethernet signals over 2 fibers. And you can connect now the unit B with a short fiber to the unit A, and it will cascade extra colors into the fiber, which is running between side 1 and side 2, or side A and side B, and connecting the units A with each other. Another unit, yellow, can be cascaded as well. It could carry SDI signals again. So each unit can carry any type of signal. You just need to know, I cannot combine 2 green units on one side of the fiber. And I always need to have a pair of A's, so a pair of greens, a pair of purples, a pair of yellows, and a pair of blues. The type of signal which is carried by the unit is defined the day you purchase it. So if you want to carry SDI, you say, I want a pair of green units with SDI. If you want to carry Ethernet, you say, I want to have a pair of green units with Ethernet connectors. And you can add in at a later time a pair of purple B units carrying a different signal. In order to carry all those signals over fiber, we need SFPs, small form factor pluggables. I think most people know those SFPs. They're placed inside Ethernet switches, for example. And they're placed in a lot of devices. They're placed as well in broadcast cameras to carry and to convert electrical signals into optical signals in order to carry them over fiber. We do offer a big portfolio of SFPs for our units. Barnfind SFPs are always transceivers. That means they have a transmitting port and a receiving port. We do not offer SFPs which have double transmitters or double receivers. The reason is they do not properly work in our devices because our SFP ports, the SFP ports of our units are equipped, are always TX and RX on the same port. Now, we do offer optical SFPs, single mode, multi-mode. We do offer bidirectional SFPs. That means I have a bidirectional signal on one fiber. There is a little multiplexer built into the SFP using two different colors. And a pair of those SFPs always works together. We do offer CWDM SFPs, meaning each SFP is transmitting a certain color, a certain wavelength. We do offer media converter SFP, such as SDI to HDMI converters or SDI to analog video converters or to electrical Ethernet converters. And we do offer IP converters for ST2110, ST2022, D and encapsulators.
Benno, just one question. That means we can use the BarnOne frame to bridge SDI signals into the IP world and vice versa. Is that right?
That is correct, and I will have an example for that later on coming up. Last but not least, we have a technology which we call high-low. That means we can double the amount of signals carrying or traveling over one 18-channel CWDM multiplexer. So we can make it 36 signals on one fiber. I will come to that in a second. First of all, we need to have a quick look at CWDM technology. It's not a deep dive, don't worry. CWDM is coarse wavelength division multiplexing, is one part of the division multiplexing, the wavelength division multiplexing technology, which is widely used to carry signals over fiber. It carries up to 18 signals on one fiber. Those 18 channels are defined by the ITU, and our multiplexers can be combined with any other multiplexer of any other vendor. They're all using the same channels and the same wavelengths. With this technology, a 100 megabit signal can travel beside a 12 gigabit signal without influencing each other. You don't need to calculate bandwidth or think about what you're using. The only thing you need to know is the length of the fiber. The longer the fiber, the stronger your transmitting laser or LED needs to be. So those 18 channels act as if there were 18 single fiber cores, 18 single fiber cables traveling beside each other. I mentioned high-low earlier on, and high-low means we can double the amount of signals traveling on one fiber from 18 to 36 by sending two signals on one CWDM channel. On one optical, passive optical multiplexer, we can run two signals, one in one direction and the other one in the other direction. This is possible with Barnfind's high-low technology and possible for signals up to a bandwidth of 3 gigabits for the moment. You can, of course, use those SFPs with third-party multiplexers. Now, what can we do with those SFPs and a BarnOne or a BarnMini unit? With BarnMini 22, in this case, for example, we can convert an ST2110 IP stream into an optical SDI stream, or vice versa. Or we can convert it to an electrical SDI stream. Barnfind is actually offering a 12 gigabit electrical SDI SFP. The next day, by just swapping SFPs, you can convert Ethernet between electrical and optical. So the electrical Ethernet could be between 100 megabits and 10 gigabits if your SFP supports the data rates. And the optical Ethernet can be multi-mode or single mode, or can even be a CWDM SFP. That means you only need to put the right SFPs in your pockets and have a BarnMini 22 with you. And if you want to control it, you can control it by connecting BarnStudio to BarnMini 22, but you don't need to control it. You just insert the SFPs and you will have the converter on the fly in your pocket. It's very powerful. If you have a BarnOne unit, or if you have a whole bunch of BarnMinis, which you would like to hide inside a flight case, we offer breakout panels in Barnfind colors to connect the sensitive optical connectors or BNC connectors to an outside breakout panel. This is just a passive panel. Of course, you can use your own, but you're more than welcome to use ours. You can arrange those panels the way you want. You just purchase an empty frame and equip it with 10 breakout panels of your choice. If you have a special connector, which we do not provide the hole for, you can just buy a blind panel and drill your own hole. Now, I would like to have a look at BarnStudio. BarnStudio is the general control tool for BarnOne and BarnMini. It offers control for all the features which you have in the frame. So that is matrix control, the control of the automatic changeover switch, which is in each frame. You can analyze input signals. If they're SDI, you can see what type of SDI the signal is. If it's not SDI, you just don't analyze it. You can organize your inputs and outputs in groups. You can create logic gates. And you have diagnose functions for the frame in case something is going wrong. So temperature control, fan control, reclocker control is offered by BarnStudio. And you can save a configuration of a frame and load a saved configuration.
And now one question more.
Yes.
If using the BarnStudio, can we monitor all SFPs in terms of temperature, optical level, and so on?
Yes, yes, we can. All the information provided by the SFPs, we are reading it out and we are displaying it using BarnStudio. We can have a look at that in a second when I switch my screen from the presentation to the BarnStudio, and we can have a look at that quickly.
Okay, thank you.
This is a very important tool to find out if your fiber is working correct and if your SFPs are working correct, because it can always be one fiber patch is dying or a whole fiber carrying with the SFPs. You can monitor if your signal is good. It is possible to control BarnOne units by third-party control systems.
Benno, I think the last page was lost. Is that right? Yeah, just
something happened.
Yeah, you were silent.
I was silent. I think that was my internet connection. I'm sorry for that. Yeah. It seemed like my internet connection was a bit.
Maybe you can go one page back.
Was it this page you are asking for, Manfred?
No, this one. This one. Yeah, you didn't say anything.
Yes, I didn't say much about this page because we're going to have a closer look later on at BarnStudio in a real operation. This page just shows that you can monitor the SFPs, but we can have a look into that in a second. I would like to shortly mention that there is third-party control protocols which can control BarnOne frames. This can be Telnet. You can just use your own Telnet client. You can use SNMP for full control. You can use SWP08 ProBel protocol, which enables matrix changes. Another tool for full control of the whole frame is Ember Plus, another protocol, which is widely spread in the broadcast market. And ROS dashboard can fully control BarnOne units. In case you don't have a Windows PC, which you will need to run BarnStudio, you can just use the web server, which is running on BarnOne frames, and connect with any Linux or Mac PC. Now, I would like to show BarnStudio a bit more detailed. In general, we control our frame via Ethernet. There's an Ethernet port on each frame, and BarnStudio finds this frame using multicast, so you don't need to know the IP address. You can just connect to the frame, and BarnStudio will find it, and then you can configure your IP address. This works even over internet. So you can remotely control your frames, which are placed anywhere in case you have a route. We can see here the matrix, the 32 cross-point matrix, which in this case is reduced to 28 ports. 24 ports are used for SFPs and BNCs, and 4 ports are used for the audio card. So this is 4 MADI streams entering the audio card and 4 MADI streams coming from the MADI card. We can have a look at the audio card here. So we can see, okay, there's 8 analog audio channels. I can see the clock range is 1FS. That means we are clocking to 48 kilohertz, and we are clocking to the incoming MADI port number 25, which is in our main matrix, this one here. So I have an incoming MADI carrying those signals, and this MADI stream is providing the clock for the audio board. Beside that, I'm using an SFP here as SDI generator. It has a built-in SDI generator, and I'm generating a 3G SDI 1920 by 1080p 60 level A. All this is displayed by the signal analyzer and fed into my matrix. You can see here, I called it SDI generator, so I have the label, and I'm feeding it to different SFP outputs, and I could as well feed it to a BNC output.
Benno, by the way, can we select a different pattern on the SDI generator, or is it one?
No, we cannot, because this is in the SFP, and the SFP is not built by Barnfind, and it's not a generator SFP. This SFP is actually used to transport HDMI, and it only generates an SDI signal if there's no HDMI signal present at the HDMI input. As soon as I connect an HDMI to this SFP, the generator will be turned off.
Okay.
As you can see here, the BNC output port number 17 didn't turn green. So I can go to my output page and have a look at the output port. And I can see here, oh, the direction is set to input. Once I change the direction to output, it goes green, and it goes green in the matrix here as well. So you have a very fast control if you have valid signals, and if your signals are present at the outputs just by the color indication. On your inputs and outputs tab, you can analyze the signals, and at the same time, you have a control of the SFP if there is an SFP present, and if the SFP is receiving a signal. You can see here, for example, RX loss of service is not activated. That means there is a signal present at this SFP. And you can see here, the signal analyzer is enabled, but it doesn't recognize the signal, so the signal is not an SDI signal, but the optical signal is present. Similar on the output section, I have a display here of the optical TX power, the optical output power of each SFP. So I can easily compare that with the connected RX SFP and see how much optical power I'm losing between my side A and side B. If I want to have a closer look at SFPs and all the data provided, I have an SFP tab, and it shows me all the data the SFP is providing. For example, RX power over here, minus 40 dBm means there is no input signal, no optical input signal. It tells me the temperature. It tells me the TX power. And if I choose a different SFP, it even gives me more choices of what I can do. All those functionalities, all those functions are inside the SFP, and BarnStudio is your interface to control the SFP. You can use BarnStudio to upgrade the firmware either via internet if you are lazy and you just connect your frame to the internet and say, upgrade yourself to the latest version, then it connects to our server and downloads the latest upgrade. Of course, you can do the whole thing offline and do a firmware upload. BarnStudio is always checking here if there's new firmware for the connected devices available and downloads that firmware automatically in case BarnStudio has a valid internet connection. You can load and save configurations from your frame to file and from a file into the frame both directions. You have the possibility to monitor what's happening inside the frame. Is both power supplies available. In this case, you can see there's only one power supply connected to the frame. And we can see here as well, there is no analog reference sync connected to the frame. This reference sync actually is only used for a glitch-free matrix switch. It's not at all required for the operation of the frame. And it does not mean that we can frame synchronize. We do transport very fast with a latency of about 4 pixels per 3G SDI signal. But we do not frame synchronize any signals. Our strength is low latency transport. Now I would like to give you a quick view at a BarnMini device. This is BarnMini 22. It looks very similar. You have inputs. You can see, aha, there's an SFP. There is my RX power, so it's receiving a signal, which is great. On my outputs, I can see, aha, I have a TX power, and I have a reclocker, which is bypassed in this case. And in that case, it's set to auto, and you can see here, it clocks to 2.97 gigahertz, 3G SDI. Those reclockers can be forced to 12G or 10G Ethernet, or even SD-SDI or MADI, or they can be bypassed. BarnMini 22 does as well offer the SFP page and the firmware upload page. Now, Manfred, is there any questions which we should maybe answer?
Yeah, in our list and our participants, there are none, as I can see, but feel free to ask your questions. Otherwise, I would like to thank you very much for your detailed presentation, Benno. I think we all got a very good overview what Barnfind can do. Especially the most important from my side would be to mention Barnfind does a latency-free transmission, transparent and format-independent transmission. That means you can use all the used or shown signals in the product or on the Barnfind frame or in the BarnMini unit. So if you do have questions, please feel free to ask them now. What we will do, we will send you the presentation as soon as possible to your email address.
As long as we are still giving you some time to answer questions, we would like to let you know as well who we are and how you can contact us. There's 2 main email addresses which you find on our website as well. And those 5 people which you can see here are the main people you would be in contact with when you contact Barnfind headquarters. Of course, in Germany, Manfred is looking after us, and there's many more people who will help you out in case you have questions or in case you have ideas. So you can follow us as well on YouTube or Facebook or LinkedIn. We would be happy to see you again. And Manfred, again, is there any questions which arose?
No, I haven't seen any.
Then I would like to thank you from my side for your participation. I hope you did learn something, and I hope I could give you a good impression on Barnfind's product portfolio. Thank you very much.
Thank you, Benno. Thank you.